Okay, so this is the problem from page 38. Last night's homework, number 5. We have that airplane, and it took off from this airport at t equals 0 hours. And we're given this formula here. So the first question is, what's the meaning of the coordinate 0 in that equation?
Is it the ground?
What's that?
Is it the ground?
It is, Connor. So right here at 0, that right there is that its height above the ground is 0, which makes sense because the airplane hasn't taken off yet. Makes sense? Any questions on that?
I have a question.
Yes.
Could the ground be anywhere on the axis? Or does it have to
Ooh, that's a good question. I would assume, even though this is not a good assumption, but I would assume that the ground would be at z equals 0. Because that's the height. Now, it doesn't help us a whole lot because, in that term, because it talks about how the airport is at 15, negative 20, 0. So the airport is not really at the origin, right? I mean, you could think about that. If you want to envision what's going on here, if you think about this being the x direction, that means if we start at the origin, the airport itself is at 15 in the x direction, negative 20 in the y direction, and then it's on the ground at 0. So that's the idea. So then the question was, after 12 minutes, the airplane flew over Bethlehem. So the airplane's going to fly over Bethlehem in 12 minutes. Where is the airport in relation to Bethlehem? So how are we going to figure out what the airport's relation is to Bethlehem?
Does that have something to do with that vector?
It does have something to do with this vector. So we have this vector that we're adding to our starting point with the airport, right? So if I look at this vector right here, what's t represent again? Time in hours. So where is a plane going to move in 1 hour? Yeah, 450 in the x direction. In the y direction, how far? Negative 600 in the y direction. And then in the z direction, 20. And that's in kilometers. It says, so everything is in kilometers there. So we know after 1 hour, we would add the 450 to the 15. So we could go, if we wanted to think about it that way, 1 hour, we would be at the point 465. Oops, why did I put a comma there? I don't know.
So which one's the base? 15, negative 20, 0?
That's a starting spot, yeah. So in 1 hour, we'd be at 465, comma, negative 620, comma, 20. Okay. I want you to get that idea because worst case scenario, you can always draw a t-table and start to get an idea of where the plane is at each, interval of time. Okay, so now we want to figure out, though, in 20 minutes, or sorry, not 20 minutes, what does it say here? 12 minutes.
Could you just
Do-
find what
Like,
12?
Find what 12 is out of that, like 60 minutes, and then multiply it by that percent.
Right, so Madison said there, and then I don't think Connor heard her, but basically what we're going to do is find out how many hours 12 minute is. So let's go ahead and erase that. And Connor, what was the actual, or Cassie, what's the question?
How would you know how much it moves in an hour?
So the hourly movement is right here. That's how much it moves in 1 hour.
Okay.
Okay. Alexa.
Could you just take that and replace t with 12 over 60?
We could do that, yes, that'll work. I like that idea, actually. We turn it to decimals in the other periods, but that'll work too. So t would be 12 over 60, and we can multiply that by 450, negative 600,
You reduce
come on,
the
20.
fraction? Does it matter?
You could reduce the fraction to, I think that's, what, 0.2? 1/5, yeah, it's 1/5, which is 0.2. So any of those would work. When we multiply that, since that's, 12 minutes is 1/5 of an hour, which is 0.2 of an hour, which is 12 out of 60 of an hour. When we multiply these, our scalar here, what are we going to end up with our new vector? Okay, so when we multiply the 12 over 60 and we scale that times our vector, our new vector is 90, -120, 4. What does that give us, Connor?
That's what 12 minutes.
That's how far the airplane goes in 12 minutes. Actually, it's not necessarily how far. It's not a distance.
It's the vector it moves.
It's the vector it moves. So the airplane in 12 minutes moves 90 kilometers in the x direction, 120 kilometers in the negative y direction, and 4 kilometers up. So to answer the question, that is where the airport is in relation to Bethlehem. So it's 90 kilometers in the x direction and negative 120 in the y direction. And how high is it above the ground? 4. So that's it. Answers our questions. Questions there?
That's it.